I'm Melissa.
I'm GM.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Jim, you didn't point at chemistry this time.
I actually pointed under the table. I was trying to be a little more discreet. So,
okay, today we're going to talk about sunscreen.
Whoa. Sunscreen, okay.
Sunscreen.
Like how it works kind of thing?
Oh, absolutely.
Oh, okay.
What did you think we were going to talk about?
Like whether you should or should not eat it.
This isn't your other podcast, Jam. We don't just talk about stuff.
We just speculate. Yeah. It is so funny how different these podcasts are.
We're going to talk about how sunscreen works.
Okay.
What the different types of it are.
Mm-hmm.
And then you're going to tell it back to me.
Okay. Deal.
Okay. So, memory jog. Test time.
Okay.
Hopefully you get an A. Do you remember the electromagnetic spectrum?
I do. I don't remember like all of it because we didn't really do that. But the idea of it is that waves have different frequencies, and some of those frequencies fall within visible light. What we can see, because it is waves like bouncing off of stuff, which is how we see.
Yeah.
And there's all kinds of waves, because there's also microwaves, which is what powers microwaves. And then we talked a little bit about other kinds of waves that we don't see, like microwaves and UV rays. And we didn't really go much further outside of that, like visible.
There's radio waves too.
Oh yeah, radio waves.
Infrared. There's lots of other waves.
And if we were doing this podcast about 20 years ago, you guys would be hearing us through radio waves instead of through the internet. So.
Oh yeah.
Yeah.
Here's a question I have.
Okay.
What is the internet? This is a tangent. We don't have to talk about it, but isn't it weird? Are there waves that are in the air getting the internet Wi-Fi to my computer?
Yeah,
That's more what I'm wondering
frequencies.
about.
Yeah, they do.
It is waves? There are waves getting my computer that are internet?
I'm pretty sure.
I don't know anything. I don't understand Wi-Fi at all. And I sometimes believe I never will. It took me a long time to even understand what the internet was.
I think it is because they started with radio.
This is such a...
I know, it really is. I don't have much to say about it.
We're probably going to have to cut this out.
Yeah, I don't have much to say, so it doesn't have to go very long. But it started with radio, and that was like, we got the like Morse code thing, figured out how to get that across to people. And then we started figuring out, let's do some voices. That'd be a little more complex. Let's do it. And that was waves. And then we started getting images and sound, started doing TV like that. And then we started doing...
how TV works either, now that I think about it.
Internet is, it's all like this level of like escalating what the wave can do kind of thing.
Yeah. Blows my mind. Okay.
But I have no idea how it works either. So that's all I got.
Great. Well, okay. So that your explanation of the electromagnetic spectrum before we diverted was great. That is a good idea. I just say it's the basically collection of waves that we have that we've categorized according to frequency and sort of their characteristics. So we've categorized those waves in different things. Now, the light that comes from the sun, there's an abundance. There's the visible light, but also the sun gives off ultraviolet light.
Right.
And I'm sure most people have heard of ultraviolet or UV rays from the sun. Those are actually a type of wave. So it's energy coming out from the sun in ultraviolet.
Okay.
And we talked about how maybe the mantra strip can actually see the ultraviolet.
Oh, yeah, we did. Yeah. From the Radio Lab episode.
Ultraviolet is just outside the visible region.
Right.
It's just barely not visible to us.
Yeah.
Same thing with infrared, but on the other side of the visible region. So it's basically like extra red, but we can't see it, and extra violet, but we can't see it.
That's so weird to me, too.
That actually has,
that actually has like a color name to it. It's kind of interesting.
So ultraviolet waves that come from the sun, however, can be damaging to your skin.
Okay.
We've heard about that.
Yep. Yeah. That still kind of blows my mind because it is like, well, it's just light though. But, you know.
But that doesn't mean it's safe.
Right. I think it's just that, like, the idea of So it's just outside of the visible range. Mm-hmm. It's the idea of like, what if I walked into a room that had a light bulb on and it was like hurting me? You know what I mean?
Yes. So there we have UV lamps that we use in the lab. And if you look directly into them, you could burn your eyeballs.
Wow. So they're, okay. Dang.
So it can even be in a light bulb.
You've created a little miniature sun in a lab.
Well, it doesn't usually let out visible light. It usually is only UV. So it only lets out UV. It's almost like a black light. A black light may be similar but weaker or something. I'm not sure exactly how black lights work, but we have a UV light so that we can see something known as UV active compounds. But that is another, I mean, it's related here, but this is another story for another day. Okay. A little too complicated than I'm willing to go today.
Okay.
So do you have an idea of maybe, knowing that UV is a wave and what you learned about waves and microwaves, what sunscreen could possibly be doing? I want the listeners at home also to be thinking. See if they can come up with something.
What could sunscreen be doing? My thought is that it'd have to like, in some way, like some people call it sunblock instead of sunscreen. But it sounds like rather than block, because not those waves are just going to go nowhere. Maybe it'd have to like bounce them or like reflect them somewhere else, because it kind of seems like that'd be beyond our control. Like we couldn't just be like, nope, you're gone, done.
Ding, 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 ding.
Is that right?
Yes, I think this is the first time you've ever gotten an almost perfect answer.
Whoa.
Okay, so
I mean, my Spider-Man one, to be fair,
that was really close, but you didn't know about dispersion forces.
Yeah, I didn't. That's true. Yeah, they didn't go into that in the movie. It's so weird.
So weird that they didn't talk about dispersion forces in Spider-Man.
Yeah.
I mean, it's such riveting information.
So that's what it's doing? It's like bouncing the waves in some way?
That's one way. So there's two different types of approaches that sunblock or sunscreen has.
Okay.
Very similar to what we talked about with microwaves. The inorganic compounds, like metals reflect microwaves, can also just reflect and divert away.
Oh, yeah.
Those waves.
I didn't think about that's what that was happening with microwaves. Yeah, I didn't make that connection, but duh.
So if you haven't listened to the microwave episode, go back and look.
Yeah.
So basically the waves come in and hit something that is impenetrable to them, and it reflects them away.
That's pretty crazy. How is a cream impenetrable to them?
It has inorganic compounds in it. So you're basically spreading around. I think the major compound used in that is called titanium dioxide.
Okay.
Which is basically an inorganic compound with titanium and 2 oxygen. And it actually is white. And that's
interesting.
why we've got the sun blocking sunscreen here.
Huh.
So that's one way that sunscreen works.
Okay.
It's doing exactly what you said. It's taking in those waves and blocking them, keeping them, like Captain America's shield.
Oh, yeah. Nice. Okay. Yeah.
They hit it and it just goes off of it.
Boing, like.
Yes, exactly.
Okay.
So that's one type. The other type is, this is a fun one, and we are definitely going to talk about this again when we talk about solar panels.
Okay.
The other type has organic compounds. This is the kind I already knew about before I started researching, or because I'm an organic chemist. It has organic chemist. It has organic chemist. It has
ground up organic chemist.
Yeah, organic chemists on your skin. It has organic compounds in it, which happen to, just like water happens to absorb microwaves and dispels that energy as heat. It has the sunscreen has organic compounds in the sunscreen that absorb the UV waves and just dispel that energy as heat.
Whoa. That's crazy to me. That really is. I'm like, it seems like it'd be so unstoppable. Like the idea of bouncing it seems like, okay, I can get that. The idea of like being like,
it absorbs that and makes it harmless. Just releases it as heat.
That's really cool. So is one of them like the more classic way? Like, did we know how to do the bouncing, reflecting kind of thing before we knew how to absorb?
Before you answer your question, I just want to say, I think that this is amazing.
I completely agree. I'm like, I didn't believe that. I mean, like my answer at the beginning kind of shows that. Like, I didn't believe that you could just disperse or like transform those waves. I thought you had to just at least redirect it. Kind of like a bullet coming at you. Like one of the best ways, really, truly, one of the best ways should be to have something that's going to make it ricochet off. You know what I mean? Like,
but then that's dangerous because in the case of a bullet, it could ricochet and hit someone else.
Right. I was thinking like that level of danger when it's like it's coming at you, it's coming fast. Don't try anything like don't try to catch it. You know what I mean?
Yeah.
It's like
But this way, it's almost as if it turns the bullet into something harmless like water.
That'd be pretty crazy. If only all the bullets could be turned to water.
Seriously. So to answer your question, I'm not sure which one came first. I would have to look in a little bit further, which I did not do.
Yeah.
But I already knew about the absorption ones. I did not know about the titanium dioxide ones because I spend more of my life in the organic realm than the general chemistry realm.
Right. Yeah.
So I can't answer that. But isn't that so cool?
Yeah, that's awesome. That is crazy.
Do you have any other questions about it?
Yeah, like what's the more common sunscreen that most of us have dealt with? Which method do you think it is used?
I don't actually know the answer to that question, but let me do some quick research and see what I can find.
Okay.
Okay, so after some research, I did not find which one was most common, but I did find that sunscreen, according to the American Academy of Dermatology, sunscreen is regulated by the FDA.
Okay.
And it seems that at this time, all the sunscreen that's legally sold in the United States is regulated and should be safe.
Okay.
So I don't know which one is most common. There's not a lot of information on that, but it does seem that it's all safe.
Okay. So it said the most common ones are the ones that have titanium dioxide and zinc oxide?
No, that said the ones that are safe, most generally recognized as safe and effective.
Have that. Okay.
So they're like the blocking kind.
So those would be the refracting kind.
Yeah, but then it says that 2 other ingredients that are not safe are some chemical ones, but those aren't the only chemical options.
Yeah, okay. Got it.
So from what I can tell, it doesn't seem to me that I can't tell. So even though we don't know which one's the most common, I can't find any reliable source that tells me that at this time.
Yeah.
I could maybe just pull up a bunch of nutrition labels. Do they have what are those called? Chemical labels on the back and see, but I don't think that information does not appear to be readily available to me. But if there is someone who knows, please let me know.
Yeah, that'd be awesome.
And a little aside, some sunscreen is not good for the environment. So if we have any biologists out there listening, please write in and tell us what you know about which sunscreens are safe for the environment.
Yeah.
Because we'd like to give a little PSA about that.
Yeah.
Okay, so before I do want to say one more thing, but before I do that, do you have any more questions about sunscreen and how it works?
So it's basically like, not really a question. I think I do want to check to make sure I'm understanding. But we can do that at the time. You want to do that?
let me tell you this one more thing. So the UV range is broken up into UVA and UVB.
Okay.
The UVB range is the one that is most likely dangerous for the majority of burns, skin cancer, tanning. That's all UVB.
Okay.
UVA is likely less harmful, is not as dangerous. The most dangerous is UVC. That is absorbed by the ozone. So we're protected from UVC by the ozone.
That's good.
That is good. Thank you for the ozone.
Yeah, thanks, ozone. Appreciate you.
So you may have heard broad range sunscreen and then non-broad range sunscreen. So, or broad spectrum sunscreen. So that just means the broad spectrum protects against UVA and UVB. So in case there's any little bit of danger from the UVA, you're also protected from that broad range sunscreen.
Okay, got it.
So I did want to address that. I also wanted to say SPF stands for sun protection factor.
I actually knew that.
You did? Wow.
I only knew that because I think it's one of those things that I like to know what acronyms are if I interact with them a lot. And it's one of those that's kind of cool to know because then everybody says SPF all the time and everybody knows like a little bit of like, oh, I'm looking for SPF, whatever. But they don't really know what they're actually asking because it's just like not knowing what $1 is, you know?
Yeah.
I want $10. It's like, well, what's $1? It's like,
well, do you know how they calculate SPF?
no, I don't know that at all.
So
I
you just
knew what the
learned
acronym.
what it was without learning what it really was.
Yeah, I just wanted to know what the acronym meant.
So, well, I'll say this. SPF is the amount of sun that is allowed through. So say you have 100% of sun hitting your skin. If you have SPF 15, that means 1/15 of that sun is able to get through your skin. If you have SPF 30, it's 1/30th. SPF 100, it's 1/100th.
So it's the bottom part of the fraction, basically. 1/15th, 1/30th, 1/50th, or whatever.
Yes.
Oh, interesting.
Oh, I did also want to say there could be some, even though it might not be dangerous for sunburn and sunscreen, for UVA can cause some skin aging, like wrinkles and making your skin look more long-term damaged. Rather than tanning and burning and cancer, it would just be aging and wrinkles. So it's useful to have broad range sunscreen, broad spectrum sunscreen.
Only if you believe there's something wrong with wrinkles, which there is not.
Jim has really good ideas about beauty and what makes someone beautiful, but also damage to your skin isn't great. So sunscreen's probably good broad range, even not to protect against wrinkles, but just invisible damage that you can't see right away.
Definitely take care of yourself.
Definitely take care of your skin. Okay, so that's it.
Okay.
That is how sunscreen works.
Okay, I think I get it.
Okay.
Ready?
I'm ready.
So, just like we talked about in microwaves, when you put metal in a microwave, it does not it's not like affected by the waves in the same way. It bounces them off. And so it's like, you're not getting in here, waves. All right, I'm a fork. You can't mess with me. So what we're doing when we put on...
I'm a fork.
Come at me. So what we're doing when we put on sunscreen is we're putting on a cream made up of, not exactly, but basically made up of a lot of little pieces of metal, or most commonly titanium dioxide.
Yeah, which is a salt. It's a metal compound. Okay. Yeah, it's a metal plus a non-metal, so it's likely an ionic compound or a salt.
The benefit being that it retains that same ability to not to reflect the UV, the waves, just like we see when it does that with microwaves.
Yes.
So
it's not exactly the same, but it's very, very similar.
Right. We don't want our skin sparking like that. Would not be good. But the idea that it can be not affected by the waves. And so we're spreading this, basically this super thin layer of metal all over our bodies.
Of a metal compound.
Metal compound salt. It sounds pretty cool to say it's a thin layer of metal, though. But metal compound salt thing or whatever. And when we do that, especially if we do it the right way and we do it thoroughly, then it reflects or bounces off all the UV.
That's right.
And keeps it from damaging our skin. Especially if it's broad spectrum, then it means it will help to bounce off all the types of UV that could hurt us. Which is that's crazy, and I'm sure there's a lot more at this below the surface to talk about there or something like that if we wanted to get crazy into the weeds.
Yeah, you could talk about electrons and why they absorb what they absorb, but that's very in depth. I didn't learn that till much later on.
And it's already simple enough just to relate it to hey, you know how this works in a microwave? Imagine it kind of doing the same thing on your skin.
Right.
It's oh yeah, that's great. And thankful that we have things like that.
Well, you only explained one type of sunscreen, though. What's the other kind?
The other kind absorbs the UV waves, correct? And transforms them.
Yes.
You said into heat, right?
Yeah. Basically, it absorbs them, and then the molecules have added energy, and that releases as heat.
Yeah.
Basically.
Which if
molecules are excited, that's pretty much heat.
And if you're out in the sun trying to not get sunburned, you're already around heat anyways, you probably wouldn't even really notice it.
Oh yeah.
So that's pretty crazy. That can actually transform the waves and render them, disarm them basically.
Amazing.
Yeah. So man, that's crazy.
And that's it. That's how sunscreen works.
Did I get it?
You got it perfectly right. And I think that this is a really fun one, and it's pretty easy to understand.
Yeah.
And it's so amazing to me that people figured this out and thought through it.
You know, something I saw the other day on the internet was, it was like a question on Reddit, and it asked like, what's something that if it was called something else, people might actually take it seriously? And somebody said, what if a sunburn was instead called like radiation damage or something like that? They had a few different words.
Radiation poisoning.
Yeah, something like that. A few different words
pre-cancer.
Yeah. To describe what it is instead of just sunburn, because it kind of sounds a little bit like, oh yeah, I just got a little burn, like just like touching a hot stove. You're like, oh yeah, you know, it'll go away. But the idea of talking about like, if you called it something that gave a little more weight to its actual potential effect,
right?
How people might take it more seriously. So I've been thinking about that ever since I read that. So it's kind of cool to learn about this now.
Yay, I'm so glad. I'm so glad that you found it enjoyable and beneficial and it fit in with what you were doing already. Well, and on that note of things making us happy, what has made you happy this week? So
yeah, something that's made me really happy is last week I got to see my niece again, my only niece on my side of the family, my brother's daughter, and which was such a nice thing. I wasn't sure I was going to get to see her again, so I saw her like the week after she was born. Yeah, and then now it's been, I think, 2 months almost exactly. And it was just so great to get to be around her again. I got to hold her way more, and she's just doing a lot more. Like, she's a little more active now. She's got a little bit more active facial expressions and moving her hands and stuff.
Babies change so fast.
Yeah, they really do. And it's like more personality coming out. And I know right now it's like, I think everybody wants to say that or whatever because they're just like enthralled by the cuteness of a baby. But it definitely seems like there's starting to be a level of personality showing up. I
love that.
And she's such an easy baby too. Like I haven't been around a ton of babies, but she's definitely easier than a lot of babies I've been around at this age. Yeah. In my opinion.
That's nice.
And I haven't had to do some of the hard stuff, obviously. Like, I'm not like the one who had to wake up to tend to her, but.
Or when she won't say that for a little while, but you don't know what she'll be like when she's teething or anything like that.
Yeah. So that was really great. We've figured out this position that she likes to be in. If she ever gets upset, she likes to be, I forget what they call it, but kind of put upside down, and you have one of your arms under her, and like your kind of elbows kind of going between her legs, and so you're fully supporting her, and your other arm is kind of holding her head in your elbow. Oh. She likes that position a lot, and she also gets to see. She loves to be able to see, so she gets upset if she's not able to like see around, because she just wants to look around. But she also likes that position for some reason. I think because it feels kind of like she's not being held.
She's independent.
Yeah, she's like kind of hovering out there. She's fully secure, but she doesn't feel like she's being like this, like,
it's crazy that
bunched up,
that babies have preferences like that.
Yeah.
There are babies who, like, every baby I've ever been around has liked to be held one way or another way.
Yeah. Yeah.
And so it's just interesting that they have preferences that quickly.
Well, my mom said that that's like one that she uses with us babies, when us when we were kids, and when she's had friends and stuff like that. So she kind of uses it as like a secret weapon. Like, oh, this baby's upset. Try this way.
I like that. I like hearing about babies. So
what about you? What made you happy this week?
This week, I feel like I talk about hockey a lot, but part of why I like it so much is because I get to share it with people that I love. It's something I really enjoy, just being in the atmosphere and the environment. I like that it's cold. I like the sounds. There's just a reason I like the sport as a whole, but I also like doing it because I can share it with people I love. I think that's something about sports. It just brings people together. And my whole life, it's done that for me and my dad.
Oh, cool.
Which that's been something, no matter how our relationship has been, it's always been so easy and fun to share hockey with him. Yeah. And even when I was a very little kid, he took me to my first game. This past week, hockey season started. So I got to go with my dad to this big event before the season opener where the players were there, and that was really cool. And then I got to go with him to opening night. And so just getting to spend that much time with my dad, he's recovering from a surgery, so he would be kind of bored and at home anyway. So it's a fun way for him to get out and do something fun. And so excited that it's hockey season and that I get to spend so much time with my dad because of it.
That's awesome. Did your other siblings take to hockey as much as you did? Or is that kind of a unique to you and your dad thing?
That has been unique to me and my dad mostly. My brother is starting to be interested because I taught him how to get the games. When I get excited about something, I talk about it enough that people around me naturally will jump on the bandwagon.
They either have to jump on the bandwagon or they have to form some level of an opinion. It's like, okay, I'm either going to join this thing or decide that I'm not going to, and why.
Or they just have to not care that I talk about it constantly, which I can think of a few of our friends that take that opinion.
I've actually been to a minor league hockey game when I was a kid.
Jam.
I just hadn't told you this because I thought you might think there's too much hope there for me to like sports, but...
Jam, you do like sports, by the way. You like bowling
The Abilene Aviators. I can still remember their logo. They don't exist anymore, pretty sure.
That's sad.
But I went to a game, maybe even more than one, when I was a kid, and I just remember it being cold and that experience like that. But
I love it being cold. That's one of the reasons I like the sport so much. And on that note, thanks, Dallas Stars, for giving me a fun place to share time with my dad. And thanks all of you for listening.
And thanks, Harmony, for being so darn cute.
Thanks, Harmony. Oh, before we leave, I do want to give my references. My references this week are, these are going to be probably repeated a lot, but the 11th edition of the Solomon Organic Chemistry textbook, the chemistry textbook available on OpenStax, and the major authors for that are Flowers, Theopold, Langley, and Robinson. And we used Wikipedia with the references on Wikipedia for facts on SPF, and we used the American Academy of Dermatology FAQ page.
And we'll always put these things in our show notes so you can actually see a breakdown of what we referenced, and you could do some further reading on that if you'd like to.
I also want to, absolutely do further research, or if you have any questions, feel free to write them in.
Yeah.
I also like to just do a quick check on our listeners around the world. And I want to give a shout out to a few countries who have had significant jumps in the last week or so.
Okay.
That would be the UK, probably because of our Great British Baking episode.
Oh, yeah.
We had a big jump of 50 listeners. In Canada, still going strong, Canada.
Nice.
We
Thanks,
had
Canada.
Thanks, Canada. A jump of almost 30 listeners.
Nice.
And we had more than double Saudi Arabia.
Oh, wow.
They doubled their listenership, more than doubled their listenership in Saudi Arabia, and a big jump by about 20 listeners in Germany.
Nice. Wow, that's awesome. Thanks.
So that's been fun to watch our worldwide reach grow, and hopefully you guys are sharing it with your friends, and that's so fun and exciting to watch.
So it sounds like they have chemistry in those other countries also. Like it works there too, which is pretty
Chemistry works all over the world.
Man, that's crazy.
And the periodic table is in the same language all over the world.
Ah.
I think there might be some exceptions to that, but none that I'm aware of off the top of my head.
Interesting. It's weird, but crazy. It makes sense. It makes sense that it should be the same. Like everybody should agree on one.
The symbols are the same all over the world. Yeah.
Well, Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. And if you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and A. Collini, who reviewed this episode.